Hi, I'm Avi Huber. I'm a product manager in the observability and management team in Oracle. Thank you for joining this session about distributed tracing in OCI. Distributed tracing is a new way to monitor application. It is a way to monitor distributed systems like microservices. It is also a better way to monitor older technologies like SOA and even legacy monolith design apps. Why do we need a new way to do it, to monitor applications? Monitor is, of course, still required to guarantee the quality of the service. But the approach of the existing APM solution is not good enough anymore. It focuses on the individual components, lacking on the bigger picture. Think about a big box store company, the delivery system of that company, something like Costco, Target, Amazon. The delivery contains the area of the warehouse, the distribution center, the delivery trucks, etc. Records of order status are generated by each of the process steps. When helping a customer, the support team uses these records to identify problems and delays. This can be done because all the steps of all the orders are recorded. And it is only useful if the records contains enough details like the warehouse name, the truck numbers, etc. Even more important, the operation team can use these records to look at the bigger picture. Things like warehouse number 3 average process time is 10% higher this week over previous week, or 23% of a large item delivery through this distribution center X missed the SLA. But there's no problem with the smaller items that go through that distribution center. This type of reporting enables proactive management, resulting in better performance. Distributed tracing, when implemented well, provides this kind of monitoring and this type of proactive management to services deployed on OCI or elsewhere. For this monitoring to be valuable, it requires recording of every step of every transaction with as many details as reasonable to collect. The application or services architecture can be quite complex, but instance-level tracing make it manageable. These two screenshots depicts the same transaction monitored with distributed tracing. Spans are the steps of the transaction. So each line of the top screenshot shows one span. The trace is the entire transaction. So trace is a transaction, span is a transaction step. Tracer is the component that runs within the code and generate these records of data that are being sent up to the server. The distributed tracing system, this is actually the portion that accept this transaction, these records, process them, analyze them, provide these diagrams, UI, etc. The other important part or component that we need to think about is tracing context, which is the idea about how distributed tracing works. This is the items that connect one steps to another to build a transaction. I can actually use this diagram to explain this. Think about an application that has 2 microservices, a browser, and a database. That will work for any microservice or non-microservice application. This is just an example. In this case, transactions start with the browser. You click on a button. The tracer, the component that runs within the browser, says looks at or intercept this activity and add the transaction context, the trace context, into the HTTP request. The context in this case is trace ID and a span ID. Both of them are being generated at the first time. The traces that lives on the first microservices read these headers that are being added to the HTTP request and looks at the tracers, can see that the transaction already exists, the trace ID already exists. it adds its own new span ID and send the transaction and set it farther down the stream to the second microservices. The second microservice B here, execute a SQL and then generate a transaction, a span based on the data that came from the SQL, send it as a span with the same trace ID. Send another trace ID says, I process the request. Send another, and then the transaction or the HTTP response go back to service A, to microservice A. Microservice A takes the trace ID that it had before, use the span ID that it already set, and said the client request that I make, the HTTP request, is returned. That's how long it took. This is the transaction trace ID and the span ID, etc., etc. Eventually, all the spans, in this diagram, 5 spans, were created to describe the transaction that happened. Actually, you may have a lot more spans because you may have a span representing some business process happen within the microservice. There may be some other calls, maybe synchronized or not synchronized. Typically, this works with HTTP traffic, HTTP protocol, but that can work with other protocols depending on the implementation of the tracer. In Oracle, for example, we implement SOAP protocols. So the processing, this type of tracing can work in SOA environment as well. The distributed tracing system at the bottom, this is the component. This is what Oracle APM is. This is what Jaeger is. This is what process all this, take all these spans, store them in a database, and provide information on them. So talking about distributed tracing system, there are currently 2 groups of solutions. One is the on-premise solution, or it may be even deployed on the cloud, but as an application, like Zipkin and Jaeger. These are open sources. But there are several others solutions. Some of them are embedded into existing APM services. On the other side of it are services that provide distributed tracing as a service. Oracle APM is one of them, of course. And this is actually where we are going. This is the future. Taking advantage of economy of scale, of course. It's a multi-service, multi-tenant service, built-in integration. In the case of Oracle APM, for example, there is a built-in integration with the functions runs on OCI. You have when you define a function, there is a checkbox. You select it, select an instance of APM, and distributed tracing that goes through these functions is enabled automatically. Other similar integration available as well. A quick word about OpenTelemetry. OpenTelemetry relate to this, but this is not really a bit off topic here. OpenTelemetry concentrate on the area where the tracer is, collecting the data, not only for traces, also for metrics and logs, which are a little bit, we will talk a little about metric later on, but logs are somewhat off topic here. This is, when you use OpenTelemetry, you still need the distributed tracing system, whether you use OpenTelemetry tracers or you use other tracers. So a quick introduction into the APM service. APM service is a native, relatively new, built about a year and a half ago, service built in OCI. It's part of the OCI. You will see the UI part of the OCI console. It's actually a part of a set of services of the observability and management services. As I'm trying to show in this diagram, these services are, APM is on the top tier here. One of the advanced services like stack monitoring, logging analytics, DB management, operation insight. These are services that are built on top of the foundational services that provide the basic metric, logs, alarms, etc. The fundamental services are something that the advanced services are using. So we are collecting metrics and traces in APM, generate metrics out of them. We send these metrics to the monitoring service where they can be used to dashboarding or to set alarms on, etc. The application APM implements distributed tracing system, as mentioned earlier. Utilizing it, there is a real user monitoring that rely on it. But additionally, it contains other functionality like synthetic monitoring, and server monitoring, which I'll talk about later on. First, the distributed tracing implementation. It is a high volume capable service. What do we mean by that? It means that we don't expect customer to enable sampling, meaning, as mentioned at the beginning, enabling customer to monitor every span of every transaction. We do support sampling if needed. Some transactions are too voluminous or too low volume to be useful, too low value to be useful. But in general, most customer will instrument all the transaction to see all the sampling, all the instances. We keep the data for a long time. We are lucky we are working on OCI. We have autonomous database to use where we can hold this data for 13 months to provide better seasonality analysis and of course going back to see how progress done over the year, over a full year, etc. To see the data, we have a strong query language that the user can use on the UI. I'll talk about it a little bit later on, and can be used by the dashboard to present the data in other means or through OCI to CLI. Most important here is the richness of the data. Out of the box, we collect a lot of data and allow you to collect a lot of data, configurable specific data for your application. When I say data, I mean every step. We already said that we are collecting every step, but how much data every step has. So if you deploy an agent on OCI, we collect the name of the OCI nodes. It's running on OKE. We tell you which OKE cluster it's running on. OKE is a Kubernetes deployment. We know the labels that assign with that you configured on that Kubernetes cluster, the name of the node, the name of the pod, etc., etc. We have hundreds of dimensions or tags that we are collecting out of the box and allow you as a user to collect many more. End user monitoring is critical functionality of APM. We do it in APM, in OCI APM with distributed tracing. So we instrument the browser to get transaction and spans from the browser. The user click a button on the UI, we create a transaction. The user load a page, we create a span. The user click load the page, we create a span. The span goes up to the server, and we have special processing in addition to the fact that it's part of the trace to get information and user information, like the geolocation based on the IP address of where the browser is running, the type of browser. Is it Firefox or Chrome? Is it running on mobile or running on desktop? The connection time, how long it took to load the page. We actually have automatic AppServer calculation that allows you to configure different values and different limits to different operations such that you can get user satisfaction out of the box. We collect all the data with the session ID. Username can be configured to be collected. Using this, you can follow a full session of a user on the system from step 1 to step 2, even if this user was working on the system half a day. Let's talk quickly about instrumentation. There are several ways to look at this. Let's start here from the left side, manual instrumentation. Open tracing define somewhat how to define how to create spans within the code. You still need a component, the tracer, that will implement the sending of this span that is being created by code into the distributed tracing system. So in the code you write, you call the tracer, you initiate the tracer, and then you say start span, end span, add to the span dimensions or tags, or into the span metrics and log entries. The second option is to do automatic instrumentation. What does that mean? In Java and in .NET, we can use bytecode instrumentation to inject this instrumentation that otherwise you do manually. The tracer component is still there. So you deploy an agent on the server. Bytecode instrumentation create the code that writes the instrumentation, that create the spans and uses a tracer. It's actually the same tracer that you normally will use to send the data out. Later technologies, things like Helidon, AppServers like Helidon and Micronaut has built-in instrumentation in them. Also, it's built in or has a component within microprofiles that can be deployed on application, where instrumentation for known items is already available. And the only thing that you need to do is to configure the tracer. It's still the same tracer to call it, to enable it and to send the spans to the distributed tracing system. Lastly, I'll mention that this is just an API, so the tracers use HTTP calls. It's pretty standard. In APM, we're using our own wire format, but we actually support Zipkin format, which is common across many other tracer components. When you're writing your own code, your own application, you want to implement the API specifically in a way that fits your component and use the API directly. This is actually offering a different view of more or less the same thing. So if we are looking at the APM on the left side, the other open tracing enable apps type of component here, or the most left green button here, green square here. There are many applications, many application languages: Go language, JavaScript, Python, Ruby, and all those that I don't even know about. Each one of them can be implemented for open tracing. Traces are available from open source or can be written. They are typically simple to write. If configured to use Zipkin, which all the known one can do, it can be sent. They can be configured to send the data directly to the APM collector. The center green square represents the tracer that we provide with APM. This tracer is not much different from the Jaeger and Zipkin tracer or the OpenTelemetry tracer. It's built for Java, with added value that it is built in for Oracle. So it will monitor any application and accept any spans that have been written, but it will collect metrics and dimension that we know about. So if you run it on OCI, we get the entire OCI out of the box configuration of collection of OCI attributes or dimension or tags. Using our Java agent uses the same tracer, but built on it the automatic instrumentation. And again, we have special instrumentation for the Oracle stack. If you're running on WebLogic, if you run SOA, and if you run higher stack Fusion middleware application, automatic instrumentation will enable visibility, open tracing type of monitoring for applications that were written way before open tracing was invented. I wanted to talk a little bit about dimension and metrics that we collect. I mentioned that at the very beginning, the value of distributed tracing is depending on how much data and how much information you have on the spans. In order to do a simple diagnostic, what traces, what microservice component how long you spend the time in each one of the microservice component, you need very simple basic data, the name of the microservice and the duration of a span. But to use this to get better information, like the example that I mentioned earlier, knowing that the data center is running slower, or in our case, knowing that one of the nodes in the Kubernetes is overloaded. Each one of the span need to have the information to know that this span is executed on this node. This span is executed on this node, on this Oracle data center, within this availability area, and in this component. And it's executing a code from application version 2.3 right now. And this information is being all added to the span and stored there for the entire time that we are storing the data for 13 months. So you can at any time compare this execution of based on this version of the code on a newer version of the code. This version number 2 of the code running on node now on the data center number 1 versus the same thing running on data center number 2. Whatever the needs will be some in the future to look at the data, you will be able to run a query and compare the data. And these are the data, we talked about the data that we are collecting out of the box automatically, but we enable you when using our agents or elsewhere if you are using your own tracer to send us more data, a lot of data. So business data. For example, you can capture the amount of money in the application during the checkout time. How expensive, how much money is being processed at that time, or money in the cart when a user times an account, a session is timing out. How much money did you lose because of timeouts? You can have this dimension that contains the amount of money. Infrastructure application is very important. You want to differentiate the area where you're running, where the application is running, as well as the type of application, and so on. The data is used, can be collected, it can be enriched on the server side. When we are just providing these capabilities now, where you can add the rules like look at the trace ID, at the customer ID, and exchange the name to the customer name, or add the customer name dimension. So when you're reporting on the data, you can see the customer names rather than IDs that not necessarily making a lot of sense to you. Other enrichment that exists is the geo information. We collect the IP address, but we show the user we populate the data with the geolocation based on actually the city, what network provider was used, what country is it on, and so on. The data that we collect is available for analytics, for dashboard, for alerting, for drill downs. Drill downs is very important, by the way. You can drill down with let's say data that you collected, let's say the trace ID, or I'm sorry, customer ID, to search this customer ID, drill down it to log analytics to search for record for this customer ID, or maybe drill down to external system that shows you information about this customer, let's say support, searching the Jira for a specific error that was captured in the code with the context of the version of the application. Something about our query language. It is SQL-like language. The actual reserved name are a bit different, fits to our needs. So you can do something like show spans or show traces. You can do group by to see aggregated data, or search for specific individual items. There are functions like a percentile and other functions that are available. And a lot of these queries are, some of them are available out of the box, but as a user, you can save them, build them into dashboards, share them with other customers, with other users of your applications, make the actual data that we store available for information that help you solve problems. As mentioned, we are utilizing the alerts capabilities of OCI, so the same alerts that you would get on down host that is enabled out of the box can be configured to be fired because of the time that it takes to load the page in some whatever configuration you care about, taking more than the average or something like that. The dashboard capabilities that are available can be utilized to show data that is metric data, as well as data that is a result of aggregation or summarize of data of trace data, which provide, of course, very powerful visualization of the data. So I mentioned at the beginning, there's more to APM than just distributed tracing. A big component of it is synthetic monitoring. Synthetic monitoring is the ability to execute scheduled monitors. I want to run a test, let's say I'm logging into the application to see that the application is running. So I want to log in and click on the one button on the home page to see that it's really up and log out. I can record a script using Selenium and now run it from any data center of Oracle. I can choose as many as I want, run it every 5 minutes. This is the best proactive way to monitor application. The script can be as complex as I want it, then go through application, make transaction, check for data, the data exists, etc. This is not the only thing that we can test. We can also test APIs. I can run a JavaScript that will execute a REST request against the database, or take the result of this request and execute a second request based on the data and check this type of capability. As mentioned, this is available from any data center, which means externally to your application. It's running from executing the code or the REST API or the page from the internet, but maybe you have applications that are available only internally. You can deploy the same monitors within your network, make it available either to monitor things in OCI or through VPN or whatever other connectivity that you have, monitor the rest of your network, even if it's on some other clouds or within your data center. Another big component that is crucial, of course, is AppServer monitoring. And if you're deploying our agents or our tracer, we do this automatically. We collect MBINs and allow you to extend it as you want. And when you're looking at things like Fusion middleware, there are plenty of monitors to read, and we have a lot of them, a lot of WebLogic metrics automatically collected, including WebLogic dashboard available. But as mentioned earlier, anything can be added. Another important component here is the fact that we have thread level monitoring. So every transaction or every actually trace that runs within the application, we take, if enabled, collect thread snapshots every 125 milliseconds, I believe, and allow you to see what the JVM is doing at the time spent, the transaction is spending on the API on the JVM. So we collect it from the entire transaction across the different JVM, and you can see how much time is spent on the specific method where a problem may occur. Additional functionality, I'm running a little bit late of time, so I'll go a bit quick here. There is a special facility for handling stack threads. Typically, you will not see trace or a span unless the thread or the function is complete. So what happens with all the stack threads? We have a special timeout capabilities that will generate spans in addition to the full time of the transaction of a trace. Span will be generated to suggest that the thread is stuck, together with the thread level data that we are collecting from thread snapshots. Allows you to find out stuck transactions, stuck calls, if it's stuck waiting for a third party call, or if it's stuck on synchronizing, or just some other problem within the JVM. Lastly, We support OpenTelemetry or Prometheus-style data collection, which means that you can give to us or upload through the APM, through the OCI service, to the O&M services, any metrics that has Prometheus exported to it, making it very rich and allow you to cover anything that you need. Thank you for listening. This page contains some links to additional information if needed. Thank you.